Hey guys, Mr. Gran here. Chapter 6, Part 1. Again, final review, sort of condensed notes. The first thing that we did in Chapter 1 or in Chapter 6 was naming polynomials. So we had two ways of naming them. They each have two names. One is by degree. These are your terms, or the names based on the degree. And then depending on the number of terms, this is the second name. That should be in your notes. In that note sheet, unless you have it burned into your brain permanently. So pause this and do it because I'm about to erase. All right, the second thing that we did was adding and subtracting. Now I'm just going to do some really quick little examples. So adding and subtracting polynomials. So if it were something like x plus 4 plus 2x minus 3, or if it was, let's say, x squared plus 3x minus 1, and we're going to subtract 2x plus 4, something like that, or maybe 2x minus 4, whatever. With this one, you're really just combining like terms, right? So as long as the variable and the exponent match, you can add them together. So the x can add to the 2x and make 3x. And then the plain numbers, 4 and negative 3, 4 minus 3 is positive 1, so 3x plus 1. Only difference with this is now we're going to switch the signs of everything in here. Really common mistake, students will only switch the sign of this one and they forget to switch it on that one. But this is x squared plus 3x minus 1 minus 2x minus a negative 4 is plus 4. And then it's the same thing, combine like terms. I only have this x squared. I do have 2x to the first. 3 minus 2 is 1, so plus x. And then I've got some plain numbers. Negative 1 plus 4 is plus 3, like that. All right, the next thing that we did was multiplying. And I'm only going to show one method here, because I think if you have foiling down, you probably don't need a lot of review. But if you're more of a box person method, this might be something that you want to put down. So let's say we'll just do a real basic one, x squared plus 2x minus 1, and we'll multiply it by x plus 4. Box method multiplication. I am going to take one of the polynomials and list it horizontally, list its terms horizontally. I need to have the sign. I don't necessarily have to have the plus to imply that this is positive. Then I'm going to take the other one and list it vertically, and I'm going to make a table. Fill in each box with the product of the row and the column that intersect right here. So x times x squared is x cubed. X times 2x is 2x squared. X times minus 1 is minus x. 4 times x squared is 4x squared. 4 times 2x is 8x. And 4 times negative 1 is minus 4. Now I can just combine like terms. So x cubed is the only x cubed. I've got 2x squareds. 2 plus 4 is 6. I've got 2 x's. Negative 1 plus 8 is 7x, and then a minus 4 for my constant. All right, the next thing we did was division. We did long division and synthetic division. Spoiler alert, you can get by on the final with only synthetic division. And that really is the bigger thing going forward, is synthetic division is what's more commonly used. Okay, so let's say we've got something like 3x to the 4th plus 2x squared minus 5x plus 1, and we're going to divide that by x plus 2. All right? Synthetic division. First thing I'm going to do is I'm going to take this plus 2 and I'm going to change it to a negative 2 in the box there. I'm going to list out all of the coefficients for every power of x, starting from the highest one to the lowest one, and zeros for any missing powers of x. So 3x to the 4th, no x cubed, so it needs a 0. 2x squared minus 5x and 1. leave a space and put a line there. The 3, the first number comes down here. 3 times negative 2 is negative 6. Now we're adding vertically. So this is the number we're always multiplying by, and then we always add the numbers vertically. So 0 times negative 6 is negative 6. Negative 6 times negative 2 is 12. 2 plus 12 is 14. Negative 2 times 14 is negative 28. Negative 5 minus 28 is negative 33. Negative 2 times negative 33 is positive 66, and 1 plus 66 is 67. Now, when you're writing the answer for this, if there is a number in here, this is always your remainder. And so we do 67 over what we're dividing by, the divisor, x plus 2. Then everything else here, it matches this. It starts out with a plain number, then x squared. Then, this 0 would have been x cubed because we were missing one here, but we're not missing any in this row. So it's going to be 33 for my constant. Then 14 goes with x. Then negative 6 goes with x squared. And then 3 goes with x cubed. And so it just follows that same standard form pattern where it's constant x, x squared, x cubed, x to the 4th, x to the 5th, and so on if it was a much bigger one. All right, last thing was factoring. Here are all of the factoring methods that you will be responsible for, and a quick example of each. Okay, so first would be GCF, right? GCF, let's say I have something like 3x cubed, 18x squared, and we'll say 15x, right? And I want to factor this out. I know there's a GCF here because all of the coefficients are all divisible by 3. So I can factor out a 3. I can also factor out an x from each one. I've got an x cubed, an x squared, and an x. So each one of these can be divisible by 1x. So I can take out a 3x. Now, that's usually not the issue with these. The issue is getting students to understand what goes in here. What you're literally doing when you're factoring is dividing something out. And so to fill in the rest, you can literally just think about what would happen if I divided every one of these by 3x. Well, this one, the 3's cancel out. X cubed over x is x squared. 18 over 3 is 6. X squared over x is x. Negative 15 over 3 is minus 5, and then x over x cancels out. So it would end up being this. And if you wanted to double check to see if your work is correct, that kind of rhymed, you could distribute the 3x back in and see if you get back to this, because these are not different. They're equivalent forms. They just look different, but they're the same equation. Okay, so the next thing was your A equals 1, or your sum and product type factoring. So this is stuff like x squared, we'll say minus 9x, we'll make it 8x, and we'll say minus, not 10, minus, shoot, why can't I think of something that will work here? We'll say minus 12, plus 12. All right, so I'm looking for two numbers that would add would multiply, to a positive 12, but add to a negative 8. So I'm looking for two numbers, so I'm thinking about my factor pairs for 12. 1 and 12, 2 and 6, 3 and 4. 2 and 6 adds to 8, it needs to be a negative 8. But I can multiply to a positive 12 if both of them are positive or both of them are negative. So our factor pair that works is negative 2 and negative 6. So this ends up being x minus 2 times x minus 6. All right, we've got two more. Now, this one works like this if there's no number in front of here. The a coefficient is 1, right? So there's no number written there. But what happens when there is a number there? Then we go to what we refer to as the Voodoo method. So Voodoo. So that would be like 2x squared minus 9x minus 5. And so if it's something like this, first you want to check for a GCF just to be sure. No GCF here, so let's take that 2 and move it over to the back, to that negative 5. Then we get x squared minus 9x minus 10. Now I want to factor it like before. What are two numbers that multiply to a negative 10 but add to a negative 9? Factors are 1 and 10, 2 and 5. It has to be negative, so 1 has to be negative, 1 has to be positive. So if it's positive 1 and negative 10, that works. So x plus 1, x minus 10. Okay, this is not done though. A lot of students stop here, but this doesn't foil back to this. It foils back to this sort of intermediate one. I multiplied the 2 over here to the constant. I have to sort of make up for that and set things right by dividing the constants by 2 now to keep things even. All right, this one does not reduce, so the 2 moves in front of the x, 2x plus 1. This one does reduce, so it's x minus 5. All right, the last one would be difference of squares. So difference of squares, this one is, if you know what you're doing, this is easy. This is easy money right here. X squared minus a number, and that number is a perfect square. That will always factor, and it's always x plus the square root of that number and x minus the square root of that number. All right, so keep working hard. Let your teachers know if you have any questions, and one more of these videos.